Welcome to Math 193 in class activity 11B, Malus law. What happens to the intensity of light from some cell phones when it passes through a polarizing filter? What happens as you rotate the polarizing filter? I want you to pause this video and think about this. You may even use the opportunity to research the information, and let's share the thoughts together. Now, the answer to this question will differ, but a sample is that when light passes through a polarizing filter, the polarizing filter will reduce the intensity of the polarized light passing through them. And the second question is, what happens as you rotate the polarizing filter? As you rotate the polarizing filter, what will happen is that the intensity of the light passing through the filter will change. As the rotated angle changes, the intensity of the light passing through the filter will also change. Sometimes it changes until it blocks out the light entirely. Objectives for this activity. You will understand that the cosine of twice an angle can be determined from the sine or cosine of the original angle. You will be able to use the double angle formula for cosine to solve trigonometric equations involving a cosine squared extent. Now you will understand to use the double angle formula to determine the cosine of twice an angle based on the sine and cosine of the original angle. Now we want to consider Malus law. Malus law states that when polarized light with intensity I subscript naught passes through a polarized filter, the intensity of the light exiting the filter, I, is given by this equation, which is I equals cos squared theta I naught, where theta is the angle between the axis of the light and the axis of the filter. Now, we will examine the function f of x equals cos squared x to better understand Malus law. I want us to answer a few questions. Part A. When is f of x equals 0? On the interval 0 is less or equal to x and x is less or equal to 2 pi. Explain your answer without using the graph of f of x. Part B. What is the range of f of x on the interval 0 is less or equal to x and x is less or equal to 2 pi? You want to explain your answer without the using of graphs. I want you to pause the video, think about these questions, and come out with some answers. We'll discuss it later. Now, you will realize if you look at this equation, you will realize that cos squared theta is always going to be 0 or positive. It cannot be negative. And so when f of x is equal to 0 in this interval, then theta must be equal to either pi on 2 or 3 pi on 2, because it is at these angles that we are going to get cos squared theta to be equal to 0. And this means that the analyzer and polarizer must be at 90 degrees to each other for the minimum or the least intensity of light to be obtained. So when f of x is equal to 0, the cosine of the angle should be equal to 90 degrees pi on 2 or 3 pi on 2. And this gives us the least intensity of light exiting the filter. And that means that the analyzer and the polarizer are at 90 degrees to each other. The graph of f(x) is shown. Is it consistent with the answers to part A and B? This graph looks like it might be related to a basic graph of the sine or cosine function. Assuming f of x is equal to a sine bx plus c, or f of x equals a cosine bx plus c, should we use the sine function or the cosine function? I want you to pause this video, think about this question, and prefer a solution, and we will discuss it together. Now, the graph is consistent with our answers with sine function and then the cosine function. Now, because you can see that with the cosine function, the raw cosine function, it peaks at when theta is equal to 0, right? When x is equal to 0. And this is also happening at the same point. We are getting the peak here. So the cosine function is the best matched expression for our solution. Assuming f of x is equal to a cos bx plus c, or f of x equals a sine bx plus c, what is the value of c? Now, what is the value of a? First one, I want to find the value of c. Second one, find the value of a. And now you want to find what is the value of b. Assuming f of x equals a cos bx plus c, or f of x equals a sine bx plus c, what is the value of b? It's b. I want you to think about this and then write the trig function you determine in parts D and E. So after solving this, finding your C, finding your A, you want to write, and finding your B, you want to write a trig function for this scenario. I want you to pause the video and try this, and then let's discuss it. Now, first we want to find the value of C. Now C is a shift along the vertical axis. Now, if you look at this graph, you can see that the midline is at 0.5. So this graph has shifted 0.5 units upwards, right? If you look at this, that is the shift, right? Shifted 0.5. And the second thing we want to look at is what is A. You can see that A is our amplitude, and it is also from 0.5 along the midline to the topmost part, which is 1, is also 1/2 or 0.5. So A is also 0.5 or 1/2. Now, assuming f is equal to a cos b plus c, what is b? What is b? And we are saying that b is equal to 2. If you look at the graph, first we have to determine what the period is. If you look at the graph, look at this part. It is repeating itself somewhere there. And so our period is pi. And we know that the period, which is pi, is 2 pi divided by the b. And so it means pi b is equal to 2 pi. When we divide through by pi, we get our b to be equal to 2. And so b is going to be equal to 2. The last part is we want to write the trig function we determined in parts D and E. So all we do is that we replace a by 1/2 We replace b by 2, and then we replace c by 1/2, and we write our equation, the trig function. Part 3. In the work in class activity 11A led to a double angle formula for the sine function. We will see how similar formula for the cosine arises from your work in question 2. Using the original function f of x equals cos squared x and the results from question 2, part G, write a formula for cos squared x in terms of cos 2x. And then part B, solve the equation in part A for cos 2x. And this is the double angle formula for the cosine. I want you to think about this. Use the equation that we just wrote in part G to write cos squared x in terms of cos 2x, and then solve the equation for cos 2x. Do this and then we will discuss it together. Now, if you remember, we had the function f of x to be equal to 1/2, which was a, cos 2 for bx, and then plus half, which was c. But that graph that we saw, that function that we saw, was the function for cos squared x. So we say that cos squared x is equal to 1/2 cos 2x plus 1/2. The next thing we want to do is to solve this equation, right, for cos 2x. So we are going to make cos 2x the subject of this equation. And so all we do is that if we multiply through by 2 here, just to clear the fractions, we are going to get 2 cos squared x to be equal to, all the 2's cancel out, so cos 2x plus 1. Remember, we are looking for cos 2x. So we can subtract 1 from here, 1 from there. So we have 2 cos squared x minus 1 is equal to cos 2x. And that is the answer that we have here. Now, at x equals 0, we have the highest intensity. So at this point, what happens is that the change will begin to be made slowly. But you can see that the cosine and the sine are steepest when they cross the midline, the vertical midline. And are fastest the closer they are to the peaks and valleys. So these are the peaks and these are the valleys. And so the change will occur rapidly when we have x to be equal to pi on 4, right? Like pi on 4, which is 45 degrees, and change slowly when x is equal to 0 or pi on 2. So the change will occur slowly here, but it is going to occur fastest at this point as it descends. Use the Pythagorean identity and the double angle formula for cosine to find a relationship between sine squared x and cos 2x. Again, pause the video, think about this question, make an attempt, and let's see how it goes. Now, we know that with the Pythagorean identity, we know that sine squared theta plus cos squared x is equal to 1, which means that sine squared x is equal to 1 minus cos squared x, and also cos squared x is equal to 1 minus sine squared x. And so having the cos of 2x to be equal to 2 cos squared x minus 1 from our previous relationship that we had, we can just replace cos squared x by 1 minus sine squared x. And so cos 2x now becomes 2. Instead of writing cos squared x, we are going to write 1 minus sine squared x. Remember, there is a minus 1 also here, so minus 1. And when we simplify this, we get cos 2x to be equal to 1. 2 times 1 is 2, then minus 1. So we're going to get 1 minus, then 2 times that, 2 sine squared x. By similar reasoning, we can prove that cos 2x is equal to cos squared x minus sine squared x. All we are going to do is that replace this sine squared x by 1 minus cos squared x, and you will get your answer. I want you to try that. Thank you for watching these videos.